Okay, we will start with the basics of numbers. Okay, we'll understand what the numbering system really means. Okay, so that we in machine learning mostly deal with real numbers. Okay, so we'll understand what those numbers are and just brief history of it, and so that we'll get better understanding of when we talk about algebra and stuff. So when the human race began, let's assume that we are the first. Like human in the world. Like, let's assume that we're Adam, okay, and Eve. When we see apples in the tree, we start probably counting it as like one, two, three, and something. That's what we call it as natural numbers. Okay, there was no need to think of anything else at the time. Okay, we just wanted to count things, and we started counting. Okay, one, two, three, and and later. As we evolved, okay, as the human evolution happened, we had the need to introduce numbers like zero, okay, where let's say we have given our one apple, okay, which we had to someone else, okay, we actually want zero apples, so we wanted to capture that motion, so we call it as whole numbers. Whole numbers includes 0 plus 1 2 3. So as we progressed, as we evolved, I think there was it's assumed that we had one apple, okay, and we have given it to someone, okay, and now we have zero apples. Okay, let's assume that someone has no apples, okay, and they have borrowed one from you, which means that already they are zero. Okay, now they owe you one. Okay, so which means that they literally have minus one apples with them. So the concept of negative numbers came into the picture. So then came the notion of integers. Integers includes natural numbers, whole numbers, okay, and also all the negatives. So then, suppose let's say we have a birthday party and we wanted to cut a cake into four and distribute it to people. Then came the notion of fractions and decimals. Okay, so this numbers are called rational numbers, where we're able to represent one number as a fraction of two different numbers. Then it is called rational number. So like so that then came the notion of rational numbers, which is denoted by q. And then there was a situation where certain numbers could not be represented as a proper decimal of, proper fraction of two numbers, like numbers like square root of 2 or pi. Okay, they don't have repeating patterns. Okay, all this put together we call it as like irrational numbers. Okay, so irrational numbers includes numbers like pi, which is equal to 3.14 and keeps repeating, and square root of 2. Okay, these are number repeating. So now, considering all the numbers, okay, which we have so far seen, okay, it's like natural, whole, integers, rational, irrational numbers, is all together called as real numbers. Okay, now these are all called real numbers, which means that we can capture all different notions of numbers as real numbers. Okay. Now there is one more number which is called imaginary number, which we do not often deal with. Okay, in machine learning, but I think I'll give an intuition of what it really means. So the early human race, as we evolved, determined that okay, all numbers could be represented in one single dimension. Like for example, if you take a scale, okay, like this, you could represent, let's say, natural numbers 1, 2, 3. We can start with zero whole numbers. Okay, there are decimals here, so we can talk about fractions. Suppose you add one more negative scale at here, and here, then you can probably talk about the negative numbers as well. Okay, and represent it in one single dimension. So what it really means that they believe that okay, all numbers could be represented in single dimension like this. Okay, positive, negative, and whole, rational, irrational, and kind of what we call as real numbers. So, but there was a situation where they couldn't represent certain numbers in the scale. Okay, I'll give an example of such number where they couldn't represent it. Through an example, let's say we have a function like this: y is equal to x squared. Okay, which means that the if you want to find a solution of this equation, where x is equal to 0, like y is equal to 0 when x is equal to 0. So this is the solution of the equation. So they were able to figure out that this parabola has a solution, okay, at the point when x is equal to 0. Now let's assume that you have one more equation like x squared plus 1. Okay, So this equation does not touch the x-axis at all. So they were not able to find the solution for this equation. And if you try to solve it, it became like x squared is equal to x squared plus 1 is equal to 0, and x squared is equal to minus 1, and x is equal to square root of minus 1. So I don't know. I mean, like they were not able to figure out how to represent the square root of minus 1. So ideally, this equation should have a solution because it's a quadratic equation of power 2. So, but they were not able to represent and find out where exactly this meets the x-axis. So, because they believe that the numbers can exist only in a single dimension, like a scale. Okay. Now later they realized that okay, I mean if they wanted to find solution for this equation, they came up with a concept called imaginary number. Okay, that is called I. Okay, and they represented I squared is equal to minus 1. So what it really means is that this, if you're able to replace square root of minus 1 as I square, then the solution becomes square root of minus 1. I mean, x is equal to I is the solution of the equation. So where does this I come from, and what does it really mean? Okay, what it really means is that if you multiply a number twice, it should I mean, if you square a number, it should lead to minus 1. There is no such number in the number line. If you square it, it becomes negative. Like any number, if you square, let's say 2 square becomes 4, it is positive. Let's say you take a negative number, okay, minus 2, and if you square, again it becomes positive. So they wanted to have a number which is square, but it does not. I mean, it becomes negative. So this can only happen, okay, when the number is like this actually. So let's say 0, 1, 2, minus 1, minus 2. So if you wanted to square a number, okay, and let's say from you are here, okay, and I mean like if you square 1, you wanted to come to minus 1. So what happens is if you rotate one time and if you rotate one more time, you reach minus 1. So this rotation is called I. So numbers were believed to be a single dimension. They added this concept of rotation as also another dimension, and that is when they were able to figure out this I square. I mean, if you're able to multiply I twice, you can reach minus 1. If you're in normal way of looking at things, like if you try to square 1, you'll end up with 1. If you try to square 2, you'll end up with 4. So here, if you try to square 1, what it representing a rotation, you rotate a 90-degree, and then one more rotation, you will end up with minus 1. So numbers became two-dimensional, which means that you have to represent numbers like this. Okay, so you have one dimension like this and the rotation dimension like this. So minus 1 I square is equal to minus 1. What it means is that you rotate I degree, and then you rotate one more I. So this becomes minus 1. So this is important when you deal with complex numbers. Even for natural numbers let's say I showed an example of an apple. Let's say this is one apple. What it really means is that it is one apple plus 0 I actually, which means that there is no component of imaginary in this. So actually we have one apple with 0 component of imaginary. So that's the reason we're able to represent in the single line. So this complex numbers is very important when we talk about I mean equations which involves rotations, and also when we talk about waves like sine, cosine, okay, and talk about the natural way of looking at looking at things. This becomes very important in engineering and science. So yeah, that's the background of the numbers.